Good morning. Welcome. Hi, everyone. Hello. I'm the guy in the front. I've got a microphone. Welcome, welcome. Hello, hi. My name is Anil Ramal Singh. I know some of you, but not all of you. So I'm a project manager for Race for the Baltic, and we're an independent non-profit that works for a healthier Baltic Sea. And we're also a project partner in the Baltic Reed project, the EU INTERREG Baltic Reed project. And this is obviously the Baltic Reed seminar. So great to see so many people here. There are actually even more listening in online, which is fantastic. Some practical information. You have emergency exits where you came in. And there's also one here. Hopefully we won't be using them, but it's good to point them out. And I want to start off giving a warm thank you to Mannheimer Swartling, our partner, for allowing us to be here in their lovely facilities. So really nice, really nice. Thank you. So this is on the behalf of the whole project team also, I'd like to welcome you here. So this is a picture from our kickoff in Helsinki in September. I'm not going to lie to you, it was pretty cold and rainy, but it was a really fun day. We looked at some wetlands and reed vegetation. So, and that was 6 months ago. Some in the project group and some associates. Hope sound is okay. So I'll just quickly walk you through the agenda. We have a packed schedule. So hope you got some coffee for you that are here. And maybe if you had some at home, who knows? There'll be a possibility for a refill in a bit. So I will give you a short introduction, and it will be a brief introduction because we have a packed schedule, and I'd rather allow time to more interesting people with cats talk, or babies, yeah, not judging. So anyway, all the speakers have 20 minutes to talk, all right, and then I'll allow about 5 minutes for questions after that. If you're online, you're welcome to post your questions in the chat, and I'll read them out afterwards. And if you're in the room, you can just put up your hand. And when it's your turn to speak, you have a microphone in front of each seat in here. So you can just hold the button the entire time you speak. So you have to hold down the button on the mic for us to hear you. All right? Yeah, great. So shortly, it's not yet, but I will be presenting Lars Geselius from County Administration Board of Östergötland, who'll be talking about breeding birds and how that's connected to harvesting reed. We have Mikael from Biokraft, who will be talking about the market for biogas and the potential of reed there. Then we'll have a short break, and please try to keep the time. Once again, we have a packed schedule, so a 10-minute break for some coffee and toilet and whatever, and some handshakes. Make connections, please. After that, we have Matthias and Elsa from Econova, who will be talking about soil production or reed potential in soil. We'll have Elof from Nordluft, who will be talking about innovative harvesting methods. And we'll have Jean-Baptiste Thomas from Royal Institute of Technology to give us a bit of a wider perspective of many of the things that we'll be touching on today. And then afterwards, you're welcome to hang out for about half an hour or so. Nobody will kick you out, but you're welcome to hang out and ask questions and things like that. And also, we're keeping it a bit brief today, and then we have some time afterwards to connect, but please feel free to reach out to me or anyone else in the project group if you have questions on the project or interesting ideas on collaborations or whatever. So, I mean, maybe it's easy with me because you've seen my face now, but anyone in the project group obviously would love to connect. Okay, so very brief about the Baltic Reed project. We kicked off in May 2023. It's a EU INTERREG project. It's going to be running for 3 years, so till April, May 2026. We have a budget of just under 3 million euros. We have 6 project partners. John Nurminen Foundation from Finland is the lead partner. We also have Arcada, a University of Applied Sciences in Finland. We have ELY, which is the government body of environment, transport, economic development. We have my organization, Race for the Baltic. We have Länsstyrelsen Östergötland, or County Administration Board Östergötland, and Åland's government. And we have all partners represented here today. And I can also say I've been working with this for a while. It's a really good mix of project partners because we all have a different skill sets and different approaches and different sort of experiences that we bring to the table. And we all have slightly different focuses in this project, which I'll be touching on. So it's turned out to be a very productive collaboration so far. And we also have a lot of fun, which is important. So this is good. Okay, so super rudimentary for some of you, but good information for others. So the common reed obviously grows along the Baltic coast for every country, all around the Baltic Sea. It grows a lot, and in many places it's overgrown. It is naturally one. I mean, okay, so let's take a step back. Unfortunately, there are a number of problems with the Baltic Sea. Eutrophication is one of the top problems, right? And that comes from a high level of nutrients that cause like algae bloomings and things like that. So in the end, it results in a lack of oxygen in the ocean, which is a big problem. There are large areas of the Baltic Sea that are actually completely dead. So reed naturally absorbs nutrients like phosphorus and nitrogen, for instance. And we see a big potential in harvesting reed and at the same time removing nutrients from the Baltic Sea. And as a result, countering eutrophication. So there are other upsides, obviously, to harvesting reed. You restore restore ecosystems along the shorelines. You restore recreational value of all our shores, and you preserve sort of the aesthetic. I mean, you bring back the landscape that we actually had originally. So, and there's so many different uses of reed. It's a very versatile material. So I'll be touching on some of them today, and some of the speakers will as well. So it's, there's a number of different things you can do with it. So a lot of harvesting is being done now by municipalities or golf courses or private people, but a lot of the time nothing happens with the reed. It just lies in the water, or maybe it decomposes in a pile, or in the best case it gets maybe on a municipal compost. But so there's a lot more we can do with it, and we see a lot of potential there. Okay, so very briefly on the main project activities. So we're looking at the legislative and regulatory framework of harvesting reed. So you require some permits and things like that, obviously. So we're looking at that for the different countries. We're also looking at producing guidelines for sustainable harvesting of reed. You can't harvest whenever or wherever you like, which also touches on a very important subject. We have to keep an eye on the water quality, like what happens with the nutrients, how does it affect fish and bird life, right? So in the project group, we will be producing guidelines for sustainable harvesting. And this is not the first project on reed ever. There's been some projects before, so we're building on previous knowledge and the previous material to produce this. We'll also be actually harvesting in the project period in these areas. And a cool side project is we're going to build a reed island. So that's pretty cool. We're going to see how that affects the water quality, among other things. And then the last part is we're going to look at different value chains for reed. What can you do with it? And the reason that we're looking at these value chains is that this project will end 2026, as you know. And the hope is that we can actually get some sustainable value chains going to get a natural mechanism of actually removing nutrients from the Baltic Sea. All right. So these are some of the commercial solutions that we've looked at, we're mapping out. Some of them have been around for decades or even centuries, like reed roofs, right? And there's also other products in the market, like reed drinking straws. So, and I can tell you who are here, we actually have some samples of reed drinking straws outside. So you can take one each before you leave. And some of you have actually already given, so don't be greedy. Take one, and leave some for the others. Other things like horse fodder is something that we've actually piloted and have come quite far in testing. And other products might be a bit more on the drawing table, like textiles or building material of biogas or biochar in a lot of the areas, small-scale testing has been done, and there's a lot of potential, but you maybe need to look at it in a larger scale. All right, so once again, really thank you for coming. Really nice to see all the engagement, and I hope you make some new connections, learn something about Reed. I know I am a lot, like every day. So great, and I will be introducing our first speaker, Lars Geselius. Welcome aboard.
Thank you, Anil, and thank you for inviting me. We had a meeting in Östergötland, and Anil said, you must come and talk about the bird and the fish and the water quality and all the impacts of these activities with the reeds. And I said, we can start with the birds, because that's where I'm most familiar with the reed birds. I started out as in my academic career as an animal zoologist, ecologist, and it wasn't that many job opportunities in that field, so I broadened it to marine biology and limnology. And but I continue my bird activities on my holiday and weekends. So it's not so much about birds in my county board office. But in this project, I got the opportunity to deal with it. I spend a lot of time in Lake Tåkern. It's Northern Europe's most widespread reed area. And that's where most of my experience about the reed birds I collect from there. And it's a protected area, and there is also ongoing reed harvesting, mostly by the Danish companies for roof material. So they are harvesting in the winter time mainly, and the total surface of reed here is 1,500 hectares. And the nature reserve allow about 10% to be harvested in this nature reserve. Yes. And what about the birds in the reed? Who are they, and what's in it for them there? Generally, we can say that the bird density in the reeds are among the highest that you can find in any southern Swedish habitat at all. So we have to deal a lot with, it can vary from locality to locality, but generally very high. It provides food, shelter, and accommodation, so to speak, for them. And the nests are building in the reeds. Either you'll see some examples. And also some birds prefer denser reed patches than the second and third generation of reeds. And the feeding grounds for the birds is not necessarily in the reeds. It can be at the water sites, lagoons, canals, and so on. So nearby to open water is beneficial in general. And if you continuously harvest areas, you find lower density of nests. And who are these creatures then? Here is one about, let's say, around 10 species that are more or less obligate living in the reeds. And you can see one pattern in common here. It's their coloration, because they are dressed up in reed coloration, more or less, and quite well camouflaged. So we have some small passerines, great reed warblers, some warblers, Savis warbler, sedge warbler, and the larger ones, the bittern and the marsh harrier. So about this bunch. And here is some example of how they are living there in the reeds. Some make kind of baskets for their nest, and they are anchored in the older, generally in the older reeds. So to the left, it's a great reed warbler nest. And they used the flowering part of the reed to form this basket, and the water rail to the right form a looser kind of basket. So very well concealed there. And here is some birds that more construct some platforms for their nests. It's the marsh harrier, the bittern, and a newcomer to our southern Sweden is the white egret heron. So they make more platforms, and also preferably the older stems or straws, not the younger, as nesting material, and they can add some twigs as well, some of them. Oh, and then we have a group of birds that are kind of in the reed areas, but not that dependent on the dense concealed reed. It can be terns, gulls, grebes, coot that are in vicinity of the reeds, but near to the water line and floating maybe if the ice is shaving off the reed, and they can use the root, the floating root areas for nesting. Yes, and here we can see then how it looks a bit then in the Lake Tåkern. Are they everywhere, or where are they, and what do they prefer? So there is a kind of spatial difference in density, this general picture. So in the lake we have more mosaic parts of the reeds, and I would say generally there we have more higher density of these birds, reed birds, than the more uniform large reed areas. It's a bit lower density of the number of nests. And how do I know that? It was my colleagues in the 80s that made study plots and walked around in these reeds and investigated nest density. So thank you to do this very hard work to walk around there in the reeds and search for the nest. But from there is some data. Generally, these birds live in a concealed environment, but on the other hand, they are pretty loud. They are singing, displaying, so they are pretty easy to locate, not by the eyes, but mostly with the ears. So to investigate. Here is how Lake Tåkern can look in reality. So you see the difference between the uniform areas and the more patchy mosaic ones. And here is an effect of this mosaic. It can remain stands of very dense bunches of reeds. And these are really attractive for some species, the great reed warbler, the bearded tit, for instance. So if you find areas with these, then better save these like bunches. Doesn't have to be big ones. And for a bearded tit, they can breed in loose colonies, so it can be maybe 5-10 nests in such a bunch, but only one great reed warbler. So it's their territory size is of course difference. A bird that now strongly affects the reeds in Lake Tåkern is the grey-lug geese, because they are eating the reeds, and they eat the green summer reeds, and they eat, and it is, you can think, how can a bird affect the reeds? But in Lake Tåkern we can have up to 29,000 grey lugs in the early autumn. So it's a feeding feast on the reeds, and continuously eating of this green fresh reed kind of tires these reeds, so it can be a degradation of it. That's what's happening now. So it's a dynamic world, the reeds. And here is a couple of species that are more widely spread out and not so many per hectares. So the bittern above and the marsh harrier. So they are more uniformly spread out in the reed area. So they have some kind of distance between them. Larger birds, larger territories generally. Here we have the great reed warbler I talked about. They live more denser, and as you can see, their pattern of distribution is not uniformly as the others. Here they are located more to the edges and small reed islands, not so much in the uniform reeds. And bearded tit as well, more densely located to these type of zones. It's quite clear when you think of it. Here is the most concealed one that you hardly never see. It's the water rail. So in this investigation I talked about, that they have study plots, they found out that the density of nests were a bit, also in this case, a bit higher at the edges rather in the center of the uniform reed areas there. Here is a type of habitat that we restore in Lake Tåkern. We call it the blue borders. It's the borderline between the reeds and the shore meadows, the wet meadows. And this is a nature management improvement activity to restore these zones for waders and other birds, animals. And it's also maintained also a bit with grazing animals and livestock. Of course, so it's one way to think when you harvest reeds, can we maybe restore some zones between some meadows and the reeds, because then we can favor some birds and some waders and frogs, etc. And here I started out kind of a list about these birds. Who are they? What do they need? When do they breed? And when is finish of the breeding? How many days they occupy the nests and with their youngs? And is it the first or second or third generation of reed stems they need? Do they want the reeds to stand in the water, or could it be drier, lower parts of the ground, and etc., etc. So, and do the birds' chicks stay in the nest, or some birds, you know, when they hatch in the nest, they escape from the nest. That's the term precocial or altrical there. So maybe in the end of this project, I can study more in this subject, and we can make up some kind of manual or consideration about the birds in respect to harvesting activities then. So some final conclusion, wrapping up this introduction of the birds. Before action, maybe map the birds. Where are they and who are they? There are a lot of local differences between the reed areas. You can adjust timing of the harvesting. You can think of, shall we harvest the summer reeds or the winter reeds, and where can we do this? And maybe keep some zones with older reed areas for the birds, and kind of figure out a smart way to have a kind of infrastructure for the birds in the areas. and monitor, evaluate, and learn about it. And also one line that I missed, you must maybe acquire a permit from either the landowner and or some authority as well. So I think I had the time pretty much. Last sentence to my Finnish colleagues. Nyt me menen inventoimaan lintuja. Was it understandable? Now we talk about that later. So we're welcome with questions to this introduction.
Thank you, Lars. Very interesting.
Mm-hmm.
Peter, question from you? Yes, hold the button in, please.
Yes, I missed a little bit in the beginning due to IT issues, but so I hope this wasn't explained before. But I just wondered about the nests. Do they typically keep the same nest year over year, or can you?
I missed that one. They, in almost 100%, they build a new nest every year because it's destroyed by snow and ice in winter. So start all over again. Engineering every year.
I have a question. So you've followed Tåkern for many years, obviously.
Yeah.
And just curious of how has the reed vegetation changed? Has it become much more overgrown, or is it pretty much the same? Or
the lake didn't almost have any reed in the 1930s because the water level was lowered, and then the expansion started. Then it was a fairly constant reed distribution for maybe 40 years. Now the grey-lag geese kind of push the reed zones backwards, or opening up lagoons, opening up channels. So this bird has a great impact. And the reed harvesting, what about that? I said 10% of the reed in this nature reserve can be harvested. And they first do the cutting, I think, in the winter time. So in the summer, they get an even stand of one generation straws. So that one they harvest the next winter, so that the straws are from one generation, because it's a better material for the roof. And these harvested areas are very attractive to the grey-lag geese, because some period of their life they cannot fly because of the molting of the feathers. So they must swim around in the lake and feed on the green, short, upgrowing straws. And then they have a huge impact. But Tåkern is a special case. You don't have the grey-lags everywhere, but that's a case of when another bird can really impact such an habitat. Otherwise, water level, the ice, the winter, the climate can be dynamic processes affecting.
Great. Good answer, thanks. And I happen to know there's a really cool building, Naturum in Tåkern, made entirely out of reed, I think.
The museum, the Naturum, has a roof cover made from the reeds from the lake.
Right.
So welcome there.
Mark?
A quick question. One of the overhead pictures showed what looked like a rectangular area of reeds with like a windbreak around that. Was that agricultural land that had gone back to becoming reeds, or was that?
It is.
You could show it.
Yeah, I know what you mean. It's backwards. It's down there. Yeah. Maybe that one. Aha, the natural one. Aha, it's the same that you see up there. That one. It's a system of protection walls to the adjacent farm, and they have created channels in a square. And when you dig these channels, you create a wall, and it's occupied by birch, a line of birch trees. So it's a kind of management for agriculture and to manage the water flooding of the farm adjacent there. So that's why this one was created, but it has been harvesting inside that square as well. I know.
Okay. Yes, we still have a couple of minutes. So.
Okay. No, I was wondering, I mean, if I understood correctly, I mean, just if you plan harvesting, I mean, carefully, and you actually do this mosaic and you do it, I mean, so in principle, it would be beneficial almost for the birds.
Mm-hmm. As a matter of fact, in harvested areas, you get this extra boost of aquatic insects. So that is, of course, food for the birds. As I said, they might have their nest in the older reeds, but they might feed in the more open or lagoons or more sparse reed density, lower reed density, because there is a higher degree of like insects and such.
And another thing I was thinking about is with the birds, I was just looking at that they were, I mean, a lot of them weren't threatening in a way, but what are the trends for these species who are living in reed? Are they actually going up? Because you would imagine that there would be more available habitats in a way.
Many of them has recently come up on the Swedish Red List, and the reason for it is maybe not what's happening about the reed, but many of them are long-distant migrants to Africa, and you have the drought, and you have climate change and effects in Africa. Many of these on the picture are long-distant migrants, marsh harrier, all the warblers, water rail, bittern. They winter somewhere else. It's only the bearded tit that might persist the harsh winters, not so many else. So you have to take that also into account. And generally, the long-distance tropical migrants has a more problematic life cycle today than before, as a rule, as a general. So it's not only about the reed for these birds. They have another parts of their life affecting them a lot.
Great. Thank you, Lars.
Was one more?
Oh, one more. Sorry, Elof.
One more short question.
Yes. Be quick about it, please.
Yes.
Just kidding.
Was harvesting only done on winter reed or?
In this lake, it's a winter harvesting activities. Not so here at the lake. It's not some interest that we have here in the Baltic reed to remove nutrient. Not that problem. It's more like a commercial activity for gathering construction materials as a resource.
What's your guess about summer harvesting of reeds? How would that affect the birds?
I think, I mean, if you have a harvested area, you harvest it in the summer, and the next year come only 1 year old straws, right? And that means you get, in these zones, you will get a lower density of birds. But if you, along channels, edges, save kind of borders with older zones, maybe don't cut the holes depending on what birds you have at your locality, of course. Do a survey of the birds and try to make a smart plan. What considerations do we take to these species? Is it a bittern? Is it more common birds here, only more regular fauna? We will harvest there. Do we have a reed area adjacent that we don't harvest? You have to think a bit of the landscape level, both locally and in a broader regional perspective, maybe. So the balance, but also some harvesting activity can benefit the birds for feeding grounds, etc. And it can benefit the coot, the grebes, and some others, like ducks that can swim in the not so dense reeds. Then they can swim around there if the reeds are in the water. And they build their own floating platforms there. They don't anchor the nest in the older stems, straws. So birds do differently. You can favor some birds here, and you can consider and save some birds there. So kind of smart engineering can be applied.
Yeah, very important, take into account. Thanks.
Yeah.
So we're out of time, but
yes.
Thank you, Lars. And Lars is around. Ask more questions to him in the break or afterwards. Thanks for shutting off the mic. Thanks. Tack. Okay, great. Welcome to the stage, Mikael Olausson from Biokraft.
Thank you, thank you.
Don't forget to turn on the mic.
I think I have.
Yeah, I'm sure you have.
It says green, so it should
It's green, it's perfect.
Should be. Can you hear me? Yeah, very good. Not perfect. Still seems. Okay, my name is Michael Wallis Olausson, and I represent Biokraft, which is a company who is producing biogas. Moving out of the camera. Yeah. I have been working with biogas for almost 14 years now. I have a background from the armed forces and from a consultant at Deloitte. Stepped into biogas 2009 by pure coincidence or by mistake, as my wife used to say sometimes, because I become a little bit too enthusiastic about biogas, which affects my family. They hear a lot about biogas around the dinner table, and I can promise you that my kids are definitely the most biogas educated kids in their classes, at least. So that also means that I would try to limit myself to 20 minutes. My kids were laughing when I said I was going to speak for 20 minutes. And they said, you will never be able to do that, but I'll try. I will talk mostly about agricultural production of biogas and the use of reed in the future. But I have to do a short presentation, otherwise my CEO will be mad at me, so I have to make a short presentation of the company as well. Biokraft was established in 2005. We are active in the Nordics, mostly for the moment, in Sweden and Norway. We also have a small satellite production in Korea as well. We have grown since 2005. We were founded by a few, five enthusiastic engineers who had been working with biogas for a few years, and they thought that instead of working in the municipality environment, it would be nice to try and see if we can do a private company out of this and see if it's commercially feasible. So we have grown since 2005, and we are now around, actually we are now 130. We are growing quite quickly for the moment. We produce around 600 gigawatt hours of biogas, but we have a target to reach 3 terawatt hours in 2030. The customer side of biogas production has been quite weak over the years. It has been strictly connected to political intentions in different countries. So we have actually, since 2005, we have grown quite coordinated with the political interest. For some years, there's been quite a lot of political interest in biogas, and then we have grown, and then it has been periods of stagnation where we have not grown at all. For the moment, we see a clear interest for biogas in the whole Europe. Biogas production is a part of the the different types of European programs, Fit for 55, Repower EU, and so on. So we see a strong demand for biogas, especially after the Russian invasion of Ukraine, where there is a need in many countries in Europe to replace natural gas with biogas instead. The main customers, for the moment, we deliver most of our gas to buses and heavy transportation, but we see a growing demand in maritime applications and also in industrial application, not only for heat generation, but also for using the molecules, the methane molecules in different industrial products. I'm not going to dig into Korea because in that case I will definitely not be able to keep my 20 minutes. But we are mostly active for the moment in Scandinavia. We have 2 large plants here in the Stockholm area. At the Henriksdal wastewater treatment plant, we actually have the Northern Europe's biggest biogas production. And it's a bit fascinating because it's located in the middle of Stockholm. So, most people don't know that there is an extremely large wastewater treatment plant in Henriksdal mountain, but there is. We also have a plant in Trondheim where we produce biogas from rest from the salmon industry. And we are building a plant in Mönsterås, and that is the plant which is actually most interesting for the rest of my presentation, for the Reed perspective. We are expanding as well. We are expanding in Skånes Fagult in the south part of Sweden, in Perstorp also in the south part of Sweden, and in Kalmar on the east side, and also some plants in Germany under construction. To understand the use of reed in biogas production, I need also to talk a little bit about what is biogas production. And biogas plant is an amazing factory, actually, we think at least, where we produce energy and fertilizers out of waste. We used to say that your waste is our energy, and that's quite true. We use waste from humans, which is mostly food waste, but also sewage. And we use waste from animals, which is mostly manure. And we can also use waste from food industry, for example. There is a lot of rest products from the food industry, which can be used for biogas. And what we do is that we collect the waste and we put the waste into what we call digesters, as you see on the right on the top. Large steel containers where we sort of mash up the rest materials or the manure into small pieces. We put it in an oxygen-free environment inside these tanks. And then with the help of different microbes and bacteria, biogas is produced. Raw biogas is carbon dioxide and methane. And we collect the methane and take out the CO2. The CO2 can then be used to replace fossil CO2 for example, in food industry, and it can also be stored, in worst case, also be stored in the special storing places for CO2. In the digesters, after the production of methane and CO2, we get the rest material, which is a soil-like product, and that is an excellent biofertilizer. It's very rich on phosphorus and nitrogen, for example, but it also contains a lot of mole substance. So we unlike what's happening with the artificial fertilizers, we also add this mole material back to the farming. So we get two great products. We get biogas, which can be used in shipping and the industry and buses and so on, and replace fossil fuels. And we get fertilizer, an excellent biofertilizer, which can be returned to the farmers. And the best thing with this is that we don't use any chemicals at all, actually. It's a very sustainable production. So we get a more sustainable farming. We get this green energy, fantastic, and we get also this high quality biofertilizer who can be returned to the farming. And also other perspectives, we get also more domestic production of energy, which is important in these days, and we get also domestic production of fertilizer, which is also very, very important in these days. Am I pointing in the wrong direction? Is it, have we lost it? Could be, could be. We have been talking about, Anil was talking a little bit about this in the beginning. What we see today is that we have a leakage from the farming industry out into the Baltic. What you do today is that you mix, if you mix manure from animals, you mix it with the fossil fertilizer, and you spread it on your fields, and you get a lot of leakage because the nutrients in the manure and the nutrients in the fertilizer is to some point accessible to the grass and so on, the crop. Thank you. But a lot of the nutrients is leaking out in the base and out in the Baltics, and of course we get this different types of a lot of nutrients, too many nutrients out in the Baltics when you get this algae blooming, for example, as a result. But a lot of the nutrients get stuck in the reed, which is it's an excellent opportunity to use reed in biogas production, because when you take the reed and you mix the reed with manure into the biogas plant, you have this process going on in the big steel tanks, and the nutrients become more accessible to the crops. So a higher part of the nutrients being spread are taken up by the crop. So what we get is that we get a positive circle where we release the nutrients out in the fields, but after passing a biogas plant, the nutrients are more accessible. So you get less leakage from the farming out in the reed. And then we pick up the reed again, take it through the biogas plant, process it, and more of the nutrients are taken back to the farming and accepted by the crops. So we get a better soil quality because we can replace some of these mole substances back. We can use less fossil nutrients, and we get less leakage and less emissions. We are going to try this in our plant in Mönsterås. In Mönsterås municipality, they have quite a lot of problems with reed in the base. And they are losing a lot of their, a lot of the base are lost into the reed environment instead. So we will, in the plant in Mönsterås, probably next summer, 2025, we will try to take in reed and use it for biogas production and see what's happening. There are some work to be done still. We know that manure-based biogas has a very sustainable value, but if we mix manure with reed, it will further increase the value, of course, but there are some work to be done. We have to check the harvesting, of course, so we can, as just been mentioned, we have to try to coordinate the harvesting with the bird life, but also with the fish life, so we don't interfere with the production of the fish. We have to also check about heavy metals, for example. If heavy metals are being picked up by the reed, we have to balance the volume of reed into the biogas production so we don't get too much heavy metals in the fertilizer. We have to check the cost, of course. It has to be cost efficient, otherwise it will not work. The harvesting time I mentioned as well. We are doing, for the moment, startups with lab tests on this. So during the summer, we will start up a simulation of what's happening with the reed into the digesters in our laboratory in Linköping. We have small digesters where we can simulate what is going to happen in a real digester. So this summer we will start with the first harvesting of fresh reed and see what's happening in a digester. We also need to check the classification of reed because today it's very tricky to find substrates which are fairly or have an acceptable classification according to RED 3. Many materials that has been used for biogas production, for example straw, which have been very favorable early on, but straw is not that favorable anymore from a RED perspective. So we have to check how reed will be accepted by RED 3. I think that's it. I think I kept my time quite well as well.
You're 1 minute ahead as well.
Oh,
well done.
That will surprise my kids when I tell them.
Yeah, I know. They should be proud. I hope they're listening online.
Yeah.
So just for anyone who doesn't know, RED 3, Renewable
Energy Directive, which is a regulatory for what can be used for what. And manure is very favorable from a RED 3 perspective, but as I said, straw was accepted before. It's not that accepted now. Food waste was extremely accepted for 10-15 years ago when the first versions of RED came. But now food waste is not that highly rated anymore. So there is a continuing process regarding RED and the development of RED. Slaughterhouse waste was extremely possible for 10 years ago, for example, but now it's not that highly ranked anymore. So it's for us, we have to develop the whole time to develop the production towards the most highly ranked substrates to put in. Because the value of the gas is connected to the CO2 reduction, and the higher CO2 reduction you have, the more value you have in the gas, and the more you get paid for the gas.
Right. Peter?
Yes, thanks. So what determines the classification of red? Is that like if it's considered to be waste, or like what makes the shift?
It's if it's waste or not, or if it can be used for something else, which is more positive than producing energy, for example. And it's also the CO2 reduction, if you have a very high CO2 reduction. Manure, for example, is very high ranked, because if you don't use the manure, you will have the methane leakage from the manure. So actually, if you use manure into biogas production, you have a CO2 reduction of over 100%, just because you have this. Otherwise, you have the leakage. So it's a combination of several things.
Yes, go ahead.
Additional. I can continue. So, and you said here that the reed will further increase the value. What do you mean by that? Do you think it?
If we have a good classification in red, and if red can see the value of bringing back the nutrients, then I think it will have a positive effect from my side as a producer. But we also hope that the biofertilizer will have a better structure, and you get more of the nutrients can be accessible for the crops.
Yes. How does the storage of carbon dioxide work that you mentioned in the beginning? When producing methane and biogas, CO2 storage you mentioned?
Yeah, that you mean so what we do actually, or what we started was to purify the methane. So the CO2 was have been a rest product for us, which we earlier on have just slipped out. It's a short life cycle CO2, so it's not as bad as fossil CO2, but we have been working for many years to find a solution for to use the CO2 in not just letting it out. So what we do today is that we install CO2 cleaning equipment. So after we have separated the methane from the CO2, we clean the CO2 from, there are some pollution left in the CO2, but then we store it in liquid form, and we sell it to Nippon Gas, for example, and other distributors who sell the gas then to, for example, food industry, where you use CO2 in packages, for example. And it can also be used for greenhouses and that type of things. But we store it in a liquid form, otherwise it's extremely difficult to distribute it.
Elof, always pushing the limit.
Can you say anything about the numbers? Do you think you can, is there a possibility for you to pay for the reed for producing biogas, or is it something you will need to get paid for?
I don't know yet, but I think
Good question.
I don't think we can pay for it.
Promise me.
I think maybe we can take it for free, but I don't think we can pay for it. But that's a bit too early, because we have to do the lab tests and see what is the yield, what is the biogas yield out of the reel. It's also a difference if we harvest it green in July, for example, or if we harvest it in September, October, and it's brown. So the earlier we can harvest it, the better yield we will have in the biogas production. But then we are in conflict with the birds and fish, so we have to find a proper gap to harvest, not affecting too much on the bird life and the wildlife.
No, but super interesting question and very relevant, Elof, because
definitely.
Yes,
definitely.
no, because that's one of the reasons we're looking at the commercial value chains in the
project. We have to earn money, otherwise we cannot build plants and
No, so obviously the environmental mission in this is the base of this project, but the commercial part is very, very relevant. Helene?
I was thinking about the biofertilizer today in Sweden, like how big is the usage more or less versus new fertilizer, and also like as a farmer, what's the price difference versus like new fertilizers, more or less?
For a farmer who use manure today, this is a positive thing, because normally we pick up the manure at the farmer's place or in his tanks, and we bring it to the biogas plant. We do biogas, and then we return biofertilizer back to the farmer. So the farmers in Mönsterås, for example, they have a bit too much phosphorus in the area. So what we do in the biogas plant is that we take out some of the phosphorus, and we use that as a fertilizer in other places than Mönsterås. And they get back a liquid fertilizer which is higher in nutrients, the nutrients they want, and they get it back for free. So for the farmers, from the farmer perspective, it's a biogas plant is a positive thing. In Sweden, I think Econova could better answer that than me, but I mean, in Sweden we use all the manure we have, but we need to import nutrients anyway, because we don't have enough manure to cover the whole need.
Thank you. We have one last question before we can go on break. Rita Huttunen is asking, have you had any challenges using fertilizer that comes from municipal waste in food production in the field?
Yes, the fertilizer from wastewater treatment plants, for example, is a bit tricky to use as a fertilizer. That type of fertilizer there are different ways to classify the fertilizer or the rest product, and the rest product from wastewater treatment plants can only be used for certain, it cannot be used in crops, for example.
Okay, great. Thank you, Mikael.
Thank you.
It's well done. So we'll take a short break of 10 minutes. And can I just remind you, because this is an EU project, we're collecting name signatures. So if anyone in here has not signed their attendance, please be kind enough to do it. The list is here, all right? Thank you. Okay, great. Welcome back. Thanks for a good session, everyone. Thanks for good questions and your engagement. So we'll kick off. Peter's always the last guy to talk in the room. Okay, so we'll kick off the second session, and I'm introducing Matthias and Elsa from Econova. Who wants to?
I can start.
Elsa, okay.
Thank you very much, and thank you for inviting us here. So we're from the Swedish company Econova. My name is Elsa Bertils. I'm a sustainability manager.
Yes, and I'm Matthias Persson, and I'm an agronomist and a product developer.
And as the title of this tells you, we will talk about how the garden market and soil production could be a future usage for reed from the Baltics. And more in particular, this kind of soil, this soil in bag that is sold for private gardeners on the hobby market. And my guess is that many of you know more about reed and harvesting techniques and so on than we do. So we will mostly talk about how soil production is working in the garden market, and also the problems that we have and the challenge we have today, to try to describe how reed could be could give us an opportunity to solve the problems. And first, just a short introduction to Econova. As I mentioned, we're working with garden products for the hobby market. And besides of the soil bags, we also produce and sell seeds for flowers and vegetables, and also for grass. And then there is tools and fertilizers, all these for the hobby market and private persons who want to garden. And these are sold with Weibulls and Hammenhögs, which is our brands. And then we have the other part of the company working with recycling, mostly organic materials with composting and sorting processes, and production and selling of wood-based fuel, and also bulk soil for landscaping projects. And even since the beginning of the company, there has been a lot of synergies between those two parts. So much of the material that comes from the recycling side is used in the soil production for the garden market. And Econova is a family-owned business with the main office in Norrköping, but we have production sites in the southern half of Sweden, and also selling offices in Denmark and Norway. And for the garden market, we are one of the large producers of soil and seeds. And we have around 140 colleagues all over the country. And then you can also see some more numbers about the size of the business. But we will today mostly focus on these 10 million soil bags that we are producing for the hobby market. And also to get you some introduction on how you produce soil. Later on, you will probably get some, you will see we say a little bit some same things that we just heard before the break, because there's a lot of things that we're doing the same, but we are from this side of the soil production side. So what we do, it's not only like digging up some soil from the ground and putting into a bag. In this kind of business, it's a little bit more than that. So first we have to produce raw materials, which could be excavating peat from peat bogs, and we also have a lot of compost sites where we produce the compost materials. And then it's also other type of raw materials that could be bark or fertilizer, sand and clay that we also can buy from other producers. And these raw materials are mixed together in different combinations depending on what type of soil we are producing, depending on what the plant is needing. And then they are packed in the plastic bags ready to come to the consumer in the stores.
Yes, and this is the bags we're talking about. And inside the bags, we use a lot of peat. Maybe more than 80 or 90% of the substrate we put in the bag is peat. So peat we use a lot, and peat is a great growing media, and because it's we can pick up large amounts of the volume, and it looks the same from time to time. It has great growing media functions because it holds water, holds nutrients, it gives structure to the soil, and so on. And the growers are used to work with peat, and it's also low in nutrient when we pick it up, and it's low in pH. So it's easy for us as a soil producer to adjust the level of pH and the nutrients inside. And as should also say, it's clean. It's like free from plastics. It's free from glass. It's free from heavy metals. It's free from weed seeds and so on. So it's a great substrate to grow in. But there is a but, and it's about the peat and the climate impact. Because peat is grown in wet conditions, it's waterlogged, and it has been formed without oxygen for thousands of years. And then the peat is from the beginning is like mostly like sphagnum moss. We call it white moss in Sweden. And because there's no oxygen, the moss will not degrade. And the thing is that we drained a lot of peatlands back in the days, like 150 or 200 years ago when we were starving in Sweden and everyone wanted to move to America because they were hungry. And then the king decided to, yeah, let's drain some land and get some good agriculture land. And we did. And then we used the land for agriculture and forestry. And then we also have this part, like 1% or so, that we use for pick up the peat. And the peatlands, there are a lot of peatlands in the world. They're like 3% of the world surface are covered with peatlands. So there's a lot. And there's also a lot of carbon inside the peatlands. It's more like 30% of the soil carbon in the world. You can find them in the peatlands. There are more carbon in the peatlands than you can find in the forest. So there's a lot of carbon. But the thing is that when we drained the peatlands and let the oxygen inside, then we have the CO2 emissions. And this is the problem because the emissions are coming all the time. And there's some restrictions in some countries to use peat. Maybe it will come to Sweden as well. And then we have to be prepared. And at Econova, we see that we will have a peat-free future, and we are aiming to be 100% circular and peat-free in 2035. Probably we have to be sooner than that. And to be peat-free, we need a large amount of organic material. And we want the organic material to be locally produced. We don't want to go to India or Sri Lanka to buy coconut fiber and bring home. So we are looking into the neighborhood here. And we like it to be lightweight because the soil has to be easy to handle, and we need to make the transport as good as possible. And of course, we still have to have clean soils. So without any strange, harmful pesticides and contaminants.
Yeah. And we have been working with peat replacers for a long time. As I showed you in the beginning, recycling has been a part of the business since the very beginning. And we're working, this is some examples of materials that we use today in the soil production that already replaces peat, but we still have a lot left to do. Fiber mulch is one example, which is a composted material from the pulp and paper industry. Biochar is one example, composted garden waste, bark mulch, biogas digestate, or the biofertilizers that Matthias just talked about. And we also have a couple of completely peat-free products in the assortment. And we were also a bit early. We had the first one, completely peat-free product we had in 2016, and won a prize in Sweden for the garden product of the year, but sold almost nothing with that product. So we were a bit too early. But now the last couple of years, the interest has been risen a lot, which is very good for us to be able to keep on the development. And here I will not talk about everything here. You can just look at the pictures and read what we see. But we are looking into a lot of different substrates to see, because we will not be able to replace peat with only one thing. We will have to look into a lot of different alternatives to reduce all the peat. So we're looking into different kinds of organic waste streams from forest, from coffee production and other things, and different kinds of manure. We're also looking into try to produce our own substrate, like the sphagnum farming, where we can maybe grow our own sphagnum moss. And then we have what is we're talking about today, the aquatic materials, which can be seaweed and algae, but also reed. And we have been looking into reed for a couple of years, and the interest for us comes from different sides. Of course, this that it could be an important part of the problems in the Baltic Sea is, of course, a driver to look into this. And the reed itself contains both nutrients and carbon, which is what we need for the soil production. And as we've heard about today, and we're talking about in this project, there is large coastal areas and lakes in need for reed removal, which gives a potential large volumes of this material. And also with this homogeneous properties that we're talking about that the peat has today. And we're also here in dialogues with actors that are working with harvesting, like Länsstyrelsen in Östergötland and other actors, that it is difficult to find usage for harvested reed today. And that gives us an opportunity to be a part of the solution. If we can find a way to use it, it will be a win-win situation. And we also have a lot of dialogues with Rolls, making these straws that we've been talking about since they are located in Norrköping. We have been have some cooperation with you, see if we can use the excess reed volumes from your production, and also have a lot of dialogues with Race for the Baltics because we cannot do this alone since there's a lot of waste before us in the value chain. So it's a lot of things making this an interesting material.
Yes, and reed as a replacement for peat. Is it possible? Yeah, we think so. And if we are thinking about how much, and maybe 5% we can replace today, maybe more. And we have to be sure of how to use the material. Maybe we can use it as it is, like just chop it. And now we're trying to see if we should mix it in a machine, because we don't have a biogas plant as Mikael has. So we are looking into if we can compost the material, and then we maybe can compost it just reed. Maybe we should mix it with something, and then we are looking into if we can use the digestate from the biogas plant to get more nitrogen inside the compost. And we also have to have the right permits. So that's a tricky one, because we have the right environmental permits. So if it is considered as a waste, you need to have the permits to handle waste. And if it's if we are going to compost the material, we have to have like the composting permits and so on. So, and this composting process takes a lot of space at our site. So it's another tricky one. And we talked about logistics before, and that is really important, because it costs a lot. So we have to figure it out how to make it cheaper. And I don't have to talk about the fish and the birds, because we know that, but still it's the same thing for our process to compost the material as it is in the digestate, because sometimes the reed is yellow, then it's low in nutrient, and sometimes it's green, and then it's rich in nitrogen. And we probably want to have a mix of green and yellow one. And also we have to be aware of the how much salt it is in the reed, and also the heavy metals, of course. And the soil bags are a low price product, so we have to be cost effective here. And a few words about the Swedish market for peat. We are in the hobby gardening, and in Sweden we use about 1.2 million cubic meter each year, not only Econova, but in Sweden. And you can buy the bags in a lot of different places, like IKEA, not IKEA, bad one. ICA and Coop and Bauhaus and Plantagen and so on. But we also have the professional gardening, the greenhouses, and the nurseries for forest plants and so on. So there's a lot of peat used today. But today, this is the last one. And the Swedish market for reed in soil. If we use 1.4 million cubic meters of peat every year in Sweden, and should replace this with like 5% reed instead, then we're talking about 75,000 of cubic meters. Probably we can use even more. So there's a lot of potential for reed in soil, I would say.
Yeah.
This is nice.
Yeah. Great. Just in time as well. I was going to give you the signal, so
okay.
You're professional. Thank you. Super interesting, of course, and we've had a lot of creative dialogue so far. Thanks for a good presentation. John Baptiste, question?
Thank you very much for your talk. Quick question. So following up on questions that we heard earlier, what sort of price are you looking at for a cubic meter of reed or of peat or other biomass sources?
Yeah. Today, if we harvest the peat our own, or if we buy the peat, the price is quite different. I mean, it's like between 120 crowns per cubic meters up to like 300 crowns per cubic meters. So if I buy the reed today, and I don't have to compost it and pay another 100 crowns per cubic meters, then it's like something between 100 and 200 crowns per cubic meters. But in the future, if I can't use any peat, then I have to find something else, and maybe the price is better then. But as Mikael did, we can't pay too much for the reed because we need to handle it. We have to shop it, we have to compost it, we need permits, we need facilities, we need trucks and diesel and so on.
And we can say it's a great a large scale for the materials that we use today that we replace peat with. Some of them that we need to treat a lot. Maybe we get paid to take care of, and some of them we pay for. So it's a lot of variation depending on how ready it is for us to use and how much permits and so on it's needed. So, but we need to figure out a way to make this happen in a cost-efficient way. Mm-hmm.
Great. Laura?
Where does this 5% come from? And follow up on that then, if you produce some products that are completely peat-free now, is that equal to the other product, or do you anyways need some qualities from the peat no matter what you use as a material?
The 5% number, it's I would say that's the best guess we have today, or we think at least we could use 5%, and also depending on how we will be able to treat it, and probably there will be a mix between just chopped reed and composted reed. Maybe we can use the reed to create a more peat-like material in other ways. So that I would say a low guess, and there is examples, not in the Swedish market, but I think in Finland that they have been succeeding to make products out of a much higher number than 5%, just to not be too large here.
Anil asked us a couple of months ago, and then we said 20%. Yeah. So he was happy then, and now we were meeting you, and then we said, say it's 5%. It's still a high number. So, but I mean, this is like composting material, and it's nothing new to compost grass. So, of course, this is like a grass compost, and as the Finnish company, they use like 100%. So, but still, it depends on what we are going to use the reed for. If it's water holding capacity, or if it is the structure, or so it's a low number, and probably much more.
So we have Peter first, then we have a question online here. Yeah.
Yeah, sorry. So kind of following up on that, I mean, if I understand it correctly, you are planning to replace peat, and this is just 5%. What do you see? What are the other alternatives, and what do you see the benefit of reed compared to those alternatives?
We are using a lot of different material. We use like the green compost from gardens, and we also use a lot of residues from the forest industry. We are composting like fiber sludge and so on. We use some biochar, and we are looking into use more of the biocompost from the biogas plants. But one of the good things with the reed is it's probably quite low in nutrient, and we don't, as the farmers, they want to have a lot of nutrient. We don't want to have that much nutrient in our bags because all the products are rich in nutrient, and some of our soils we need to be low in nutrient. So it's better for if it is low in nutrient, and the yellow reed is low in nutrient. So we like that, and the farmers don't like it.
Yeah, so you could say it's easier now to find materials that has high in nutrients, and peat is not. So we're looking into different materials that is not high in nutrients to try to like balance with other kind of composts.
Thanks. And Jared Luxton online is asking, have you thought about piloting more premium products that are peat-free or less peat? Do you think the customers would be interested?
Yes.
We see that they are, and then it's a balance how many are ready for that. But we also want to not only have the premium product for that. We want to reduce in the whole assortment. Yep. But of course, that is the first step. That is what we have today, a couple of peat-free products that is like connected to those who are ready.
The thing is, today we have these peat-free products, but we also have this peat-reduced product. So we are use less peat and more compost and more other stuff today. But they are not totally peat-free, but peat-reduced.
And follow-up question from me, the product that you launched in 2016 that didn't sell, was it because the price was too high or people didn't understand the qualities of the product, or?
Both.
Okay.
But no one was talking about peat 5 years ago. It's not something they do today. And most of the people don't know about peat. They think it's a bag of soil. So that's the thing. And yeah.
Yeah, good answer. Okay, we have to move on, but Mats, go ahead.
Regarding your soil bags, do you have also bio-based packaging?
Yeah.
Plastic. Yeah, we are not bio-based, but we are increasing the part of recycled material. I think we're at 50% now recycled, but it's always continuing to try to rise, working together with the packaging.
Okay, great. Thank you so much, Elsa and Mattias. Tack. Great. And I'll welcome to the stage Elof Winroth from Nordluft Automation. Har du på micken?
Thank you, Anil. Can you hear me? I guess you can. Good. So I'm Elof Winroth, founder of the startup company Nordluft that develops different drone solutions. Drones have historically and still are mostly used for collecting data with different kind of sensors like cameras, lidars, radars. That's great, but there's more potential. Drones can be used for physical work, as we see to the right here, for deliveries, for harvesting trees in forest, and a lot of other applications. But I think that this area can be expanded even more. Physical work applications for drones. So that's why I founded Nordluft. And we decided to make, after considering different options, we decided to develop a spreading system made for forestry. Why is that? Because spreading in forestry today comes with quite a few challenges. The terrain is tough, so ground machines, they cannot access the full forest. They are expensive, they are slow. And you can also use helicopters, but then you don't have so good precision and you can't handle small forest plots. There is a current demand in a few applications, and the safety concerns for using drones are not there because in forest the risk of flying over people is low. So we start with bioash recirculation and forest fertilization, both with strong climate impact, strong positive climate impact, I should say. But there are a few other interesting applications like seeding, forest firefighting, last mile delivery of forest seedlings, herbicide spraying, etc., etc. But how do we make drones compete against such monster machines like that, weighing 25 tons? We do it like this, or this is our plan, I should say. So we have a swarm of cargo drones, quite capable, about 40 kilos of payload each, that operate in shuttle service between the work area where they release the cargo and our base station, which is this vehicle. And because the distances in forestry are small, and because drones fly very fast, we get a good capacity. We can actually reach a spreading capacity of up to 7 or more than 7 tons per hour, which makes us competitive against the current methods. So I should say that key to achieve this is quick refills on the ground. So we have equipment for this. And key to lower the total cost is to have this system operated by only one person. But I'm not here to talk about this, but I should talk a bit more about this. So this is a few pictures from our prototyping. Here we spread forest fertilizer in northern Sweden. We have currently a prototype system of 3 drones operating the way we do in shuttle service, and we don't have, we still have manual refill. So I'm the one with buckets, running fast to fill the drones coming back. A short movie clip. Yeah. So one being loaded, going out for spreading, and one coming back for refill. But Reed, why am I here? This is actually the place where I grew up. It's at Nämndö in Stockholm archipelago, about 50 kilometers from here. And it's a bay surrounded with a reed, as you see here. So when I lived here until I was 14. And during this time, I saw that the reed expanded significantly. And my family, we used this material. My mom took care of it to make her vegetables grow better. And she also took care of this floating seaweed, tong, bladder wrack. So it's quite natural for me to recycle the nutrients from the Baltic Sea into beneficial stuff. But this is hard to do manually. I've experienced it with sai, lie, and krattor. So we need to find solutions to make this rational. And there are ways. Different methods involving different kind of machinery. Some all have their pros and cons. But no, I don't think any current method will make this possible in large scale, because there are too many drawbacks as I see it. Of course, we need to develop applications for the material, like we heard, and we will hear more from Jean-Baptiste later. But the harvesting is key to make this happen in large scale. And it needs to happen in large scale to actually help the Baltic Sea. So these machines, these methods, they are either labor intensive, maybe they work for solid ground, but not for the watery part, or the opposite. Maybe the collection of material is automatic, as we saw with that solution. Maybe it's more manual, like in some of the other applications, methods. So I think there must be something better. And I reached out to a few people, and I met Thomas and Robert from Initiative Ute that are actually here present today. They are enthusiasts and entrepreneurs in establishing wetlands. And they also need a better way to maintain these wetlands. Maybe we have 30 seconds for them to describe what they do.
Yeah, thanks. Well, Thomas, I'm Robert. Well, what started as 6 residents at Ute with the first pike wetland that was ready in 2015 is now 4 pike wetlands at Ute. A restored waterway, Källdiksleden, a floating wetland taking care of free phosphorus in the Baltic Sea, a number of conferences, Baltic Sea Water Talks, a number of corporate partnerships for product development and so on, education. And the vision is to establish Ute as the Ute Living Lab, a place for education, research, and product development.
Thank you. Now, so we identified the need of better methods for harvesting reed, and for a bit different purposes. Thomas and Robert, they need to maintain their wetlands for conserving fisheries, but I mostly see the purpose to remove biomaterial, to take out nutrients from the Baltic Sea. But we need better methods, so we joined forces and we applied for a project at Resource, and we was granted some financial resources to develop a concept for drone-based reed harvesting. The initial idea was to use our swarm technology for drones, so multiple drones covering an area to achieve efficiency and capacity. But join this with harvesting technology. This is a bad illustration, but what I'm thinking is that under the drone, we have a cutting equipment that also collects the material. And even if a flying lawn mower can't be that high capacity and efficient, we use multiple units. That's why we could get really strong capacity. I've made some quick calculations, and I think we can reach up to 4 tons per hour with this. But this was the initial idea. After getting more deep into the technology, we realized that there are challenges flying lawnmowers. One would be that we cannot fly straight above the reed that we cut, because then the airstream would fold all material, so we can't cut it easily. So we must have the cutting mechanism hanging underneath, or located quite much in front of the drone. We haven't decided yet if that's too much barriers for us, or if it's still a good solution. We are evaluating other setups. A promising alternative, I think, would be to use drones only to take the material from the harvesting vehicle to shore, because that's, I would say, it's the most important barrier. This environment, you can't, I don't think there is any vehicle that it's cost efficient to move the material in a good way. But with drones you can, because the distance is small and by flying you are fast. So one way would be to use drones for moving the material, but use maybe a manned vehicle for cutting, like the hydrocopter we saw there. If you have input in this process, because it's a concept development project, I would love to hear it, either now or later on. We develop technology. We are skilled in drones technology, but we're not skilled in the whole field of possible technologies, and we're definitely not experts in reed. Thank you.
Thank you, Elof. Really inspiring, cool stuff. Questions, anyone? Yep, knew it.
Where are you? Thank you, very interesting. So where are you kind of in the project, this resource project? How far have you come and how much do you have left? I'm thinking crazy ideas.
So the project is concept developing only. We said majority of the budget will go to concept developing, and if we see that we can develop some prototype of a key component, we will do that. But we already have the drones available from our other development. So what I was thinking initially was to develop the actual harvesting mechanism, the cutter. But currently we evaluate which concept will be most promising. If it's only flying drones or flying drones together with other kind of technologies.
So how much time is there left in the project?
About half the project, 6 months left. It's 1 year in total.
And what is the main cost? Is it the actual drone, or is it kind of the energy to run the drone? It's like, how should you think about, like, keep down the number of drones or the weight, or what?
The way to reduce cost is to make it work with only one staff, one personnel in place. That's key, I would say. And also to make the technology robust enough so you can use it not 24/7, but 8 hours per day.
And to keep it to just one person controlling it, does that mean you should use as few drones as possible?
No.
No.
No. Key to our concept is to have the drones autonomous. So one person monitors operations, but there is no pilot controlling each drone. It's they are navigated by GPS signals. Yes. Please.
Yes, I would like to know what is the maximum load that the drone can carry at the moment, or is there like possible to increase the amount?
So our prototypes have carried 30 and 12 kilos each. Our commercial version will carry about 40 kilos. You can make them bigger, but we would like to keep them in a format so that you can lift them without load and without battery.
And do you get to put them like 4 dots that they carry the same weight or the same lift and cooperate? Is it possible?
Yes, it would be. But single individual loads and then working in shuttle service, I think it's a more straightforward way.
Okay. Örjan in the back.
I should probably know this, but what is operating time for each drone? I mean, you need to recharge them.
Yes, on a battery, they will operate for about 30 minutes. But then we plan to have, we have multiple batteries per drone, so we keep them in operation the full day. And a good idea would be to have the same drone platform for our forestry applications as for this application. Because if we want to collect the nutrients from the Baltic Sea, we need to focus on the summer month and if it's even, it's maybe further limited with if we need to take special care of birds and fish, and maybe not cut the whole summer, but cut for only some time.
Great. And yes, okay, go ahead.
There is one comment. I have some students working on this transportation problem in Turku University of Applied Sciences, so we could have a discussion later. But in my understanding, when I've talked with the cutters, like in 1 hour what you cut in the water, you need 4 hours to collect it. So I would stick on this problem of transporting the masses and not with the cutting, because the cutting is not the issue at the moment as much as the transportation.
That's probably a good way forward.
Thank you, Olof. And I can also mention, like, we happen to have the inventors of the hydrocopter in the room, Sjöutsikt, which is a really cool creation built from scratch. So I think you'd have a lot of exchange, the three of you. So we lock you in a room on the top floor. For 3 hours, you come out and you have everything solved. Okay?
Okay.
Thank you, Olof.
Thank you.
Great. Great. So, to our last speaker for the day. Last but definitely not least, Jean-Baptiste, welcome on stage.
Thank you for having me. So, hi everybody. I see a couple of familiar faces in the room, but I'll introduce myself. My name is Jean-Baptiste Thomas. I'm a researcher at KTH, the Royal Institute of Technology. And I haven't really worked with Reed that much. I work with other things. I'm a sustainability person. I work with environmental analysis tools like life cycle assessment and material flow analysis. And my journey in research has taken me into the world of Reed, mainly through the project that I did as part of my postdoc. So I'll be presenting that in a moment. And then I'll also go through some slides that are the main result from a thesis student who I think is joining us online, ELY. And she is, well, she became my main source of Reed information for several years. And we have a manuscript on the way, so I'll be presenting that in a moment. Right, so I understand that, well, given the introductions and the presentations we've had, I think we all understand the problem of eutrophication. So I can breeze through this slide, but we all understand that, of course, marine biomass has a role to play in helping to reduce eutrophication and to better manage our nutrients. In particular, I think it's important to highlight, really to underline the case of phosphorus, because it hasn't been mentioned today, that phosphorus, of course, is a limited resource. It's finite. Primarily, we get it from mined phosphate rocks. And there are two sides to this coin, not just trying to reduce eutrophication in the Baltic Sea, but also trying to identify renewable sources of phosphorus to underpin food security in future. So that is an important thing not to forget. Another benefit of Reed, not just removing nutrients to reduce eutrophication, but also potentially finding a new source of phosphorus for us to use long into the future. So nitrogen and phosphorus typically consumed following this green pattern here in a linear way through human consumption systems, and they end up in marine environments, but also soil stocks. And the aim of this postdoc project was to look at how marine biomass can play a role in closing that loop. So we included 7 different cases that were chosen around sort of active cases in Sweden. It includes farming of sugar kelp on the west coast with formerly Koster Älg, now known as Nordic Sea Farm. I did my PhD with that project, Sea Farm, which laid the foundations for Nordic Sea Farm today. Blue mussel farming on the west coast, mussel aquaculture in the Baltic Sea at Sankt Anna, which is now, I believe, a site that's been taken over by ecological. Ascidian farming on the west coast was also included. And then there were cases of wild biomass harvesting, so the management of the invasive Pacific oyster on the west coast, harvesting of beach cast seaweed in Gotland, which I'll mention in some detail during this talk. And then, of course, harvesting of reed in the archipelago here. And that was work that we used. We worked quite closely with Southwest Finland, with Joachim, to collect information for that case. So very quickly, here are some slides with some numbers. How many people in the room are familiar with LCA? Can I just get a show of hands? Okay, good. So if I breeze through this slide, which is, I'll just make sure that we're all on the same page here because I can't see people raising their hands online. But LCA is an impact assessment method that allows us to sort of quantify environmental impacts across a range of different impact categories, so eutrophication, climate change impacts, for instance. And it allows us in particular to compare services, products, and function. Having said that, this figure here, on the left-hand side, you can see the eutrophication impacts, and on the right, you can see the climate impacts of the 7 different cases. Now, each case has a triple bar, and that's because we were using multiple functional units. So please ignore that for now. But the key number that I'd like to draw your attention to is the red number underneath each graph. These are called nutrient ROIs and carbon ROIs. Now, ROI is return on investment for economists. So just think of the amount of nutrients you need to invest into a system in order to get nutrients out of the system. So this is your return on investment. So when we're talking about seaweed farming, there are some nutrients that need to be invested into seaweed farming. For instance, in the hatchery, you have to have nutrient-enriched water to grow your juvenile seaweed that you can then deploy to sea. And then at sea, they might take up nutrients. So life cycle assessment will try to account for the whole value chain, all of these different inputs and outputs. So same for climate impacts. Of course, harvesting reed, in the case of Southwest Finland, requires these trycksår machines, I believe they're called, from northern Sweden. This amphibious harvesting machine that we actually saw pictures of before. And those are relatively fossil intensive. They require a big engine to operate, to move through the water and so on. So there is a carbon emission in exchange for the carbon uptake. So this is just the idea here with the return on investment is just to highlight that despite having these costs in order to have the harvesting activity, there is still significant potential for carbon uptake and for nutrient uptake, positive return on investments in both cases. The postdoc project also served to explore the future potential of marine biomass in closing the loop in Sweden. So these are 2 Sankey diagrams that are presenting the present case on the left and future scenarios 2050 for the harvest and utilization of these different marine biomasses. The unit here noted in phosphorus because that was the main focus of that project. So we're not talking in tons of reed or tons of beach cast. If you're interested in those, they're in the supplementary material and actually I think in table 3 of the paper, which of course I can share with you later. So important thing to say here is that based on the research that we did when we put this data together, as far as we could find, very little reed was actually utilized. So I think we collected most of the information for this in 2018, 2019. So of those that we spoke to, including Joachim, very little reed was utilized. Mostly it was dumped by the side of lakes. But it has significant potential. And the 2050 scenarios that we had, again, there's a description of how those scenarios were calculated. I think I just tried to check, but off the top of my head, I believe the 2050 scenarios for 230,000 tons of wet weight reed, if I remember correctly. So that was a plausible but very optimistic scenario for the harvest of reed in the future. And that Sankey diagram depicts sort of potential use cases of the reed in some detail. So this is the nice graphical abstract, same figure, but pretty. So I wanted to show it off. But the main conclusion of that paper was that we could be harvesting as much as around returning to human consumption systems as much as 10% of the phosphorus emissions to the Baltic Sea. following these plausible scenarios. And as you saw from the previous slide, Reed plays the lion's share in that return to human consumption systems. Of course, it depends how we return it to human consumption systems and what we can offset in terms of mineral usage in order to secure food security. So it's a complex thing, but certainly there's a lot of potential. Now to ELY's thesis. So ELY spent around 6 months, and then afterwards the process continued for a long time as we've been developing this paper ever since. She has been looking into the Reed innovation system. So she did a stakeholder mapping back in, I wish she was here so she could tell me, but I think it was 2020 or 2021. So she did a stakeholder mapping, tried to understand different pathways for the products. She conducted a number of interviews, maybe with some of you in this room, and tried to understand the environmental benefits and costs and the hurdles also. So of course, we understand that Reed evolves over time. There are different potential products that can come from the green or the more brown Reed. There are different benefits or hurdles associated with this. The landscaping, the permit landscape is complex as well. There are lots and lots of complexities across this. So just like any other part of the bioeconomy, biomass changes over the seasons, and that is a major challenge, big hurdle. And of course, we have lots of different potential products. So this is a word count, and I believe this is a, so the size of each word is determined on based on the number of times it occurred during the interviews. So she did a word count of keywords from the interview transcripts. So yes, lots of different potential products as we've been seeing. Now on the left here, two more word counts on this slide. On the left, you can see the potential benefits of increased Reed harvest. So again, a word count from the interviews. And on the right, key hurdles that have been experienced or are being experienced in development of these value chains. Again, hopefully this will be published in the next few months. I know I've said this to some of you 2 years ago, possibly. But if you're interested in getting your hands on this, I would happily share ELY's thesis with you. Just send me an email. And then another part of her thesis was looking at these different value chains. So at the time, it was the first sort of list of different product pathways associated with different kinds of benefits that I had seen. So this may be aging a little bit now, but we, again, will hopefully get it out fairly soon. So last part of the postdoc project, one of the last papers that emerged from that was working more with the case of beach cast in Gotland. Now, I want to highlight this because there are a lot of similarities between the harvest of beach cast and the harvest of Reed. Both are wild, natural biomasses, though both are also increasing, reportedly in sort of their occurrence. You find more reed beds. We're finding more and more beach cast washing up on the beaches around the Baltic Sea. Both are perceived as a nuisance or removed for aesthetic reasons. In Gotland, it's to clean beaches for tourist access and also to improve water quality. So the removal of beach cast in Gotland is actually paid for by LOVA, which is this local water protection projects that they have funded by the local municipality. So when it comes to beach cast harvest, there are lots of different costs associated with it and, of course, benefits. As mentioned here, and you can see in the figure here above, these are numbered here. You've got, of course, the costs for the harvest itself. You've got physical function changes that are happening to the beaches, habitat changes, effects on biodiversity, changes on recreational opportunities, and so on. Of course, greenhouse gas emissions as well. So the issue that's being faced with beach cast harvest in Gotland now is that it is entirely operating based on subsidy from the LOVA system. And we need to find a way to make this what we call genuine blue growth. So on the top right is a quadrant that was produced by my colleague Linus Hasselström, who is an environmental economist who works with me at KTH. And he has been differentiating different types of blue growth. So you have genuine blue growth is one that is profitable and has environmental benefits. So this is what he considers to be genuine blue growth. Then you have conditional blue growth with environmental benefits, so public benefits, socio-economic benefits, including environmental externalities. But it might not be profitable from a private perspective. So down here in that corner of the quadrant is where Beachcast and I think Reed also lies today. We need to find ways of developing policies, of trying to better understand these benefits, these costs, and of course to evolve value chains so that they're more profitable, so that we can reach this sort of genuine blue growth quadrant. And then things should start. It's kind of like a diesel engine. Once you get it started, it'll hopefully gain momentum and be able to run itself without depending on government subsidies that could just be switched off at any time. So it's a race against the clock, you could say, and we really need to find both push and pull mechanisms at a policy level and lay those knowledge foundations to make sure that we can get there quickly. So that's the presentation. These are two questions that I've been wondering a lot about that I just want to leave you with. What do we need to improve these sort of policy landscape conditions for reed harvest and use today? What kind of information do we need, and how can we communicate it to the right people to push us across into the genuine blue growth quadrant? And I also would like to highlight that as a researcher at KTH, I work with a lot of master students like Elia. And if you're interested in doing LCA work, for instance, for your value chains or other types of assessments, I have access to a really excellent pool of master thesis students every year. The season is usually September, October for pitching good ideas to students. So if you have projects that need LCA work conducted, don't hesitate to reach out. I can maybe, if we can find an interesting project, we can pitch it to a student and get somebody to help you with that. That's it for me. Thank you.
Thank you very much. Very good presentation. It is a race against the clock and also a race for the Baltic, they're saying. But no, super relevant and really ties together everything we've spoken about today. Any questions? Jens?
Do you know how much the return on investment in carbon would change if you used renewable fuel like HVO?
To run the trucks or...
Yeah, or similar machines.
Not off the top of my head, but it would improve. I remember the main cost was from operating these fossil energies, fossil fuels with this machine. So I would have to compare the performance of this particular one that you just mentioned with fossils, and then have to rework the model to figure that out. It would probably be better as long as the fuel performs better. Getting tired.
Mats, yes.
Can you come to the Åland Islands and give this speech in September?
We can talk, yeah.
Yes, Peter?
So kind of, I guess, summarizing, when you compared all these different biomasses, so like, how would you say that reed stands out? Of course, it's a big chunk of the phosphorus potential, but that's, yeah, if you put in your own words, where do you see the most relevant application for reed, or like where does it stand out compared to the others?
So in order to close the loop and remember that the framing for that project was really trying to find phosphorus, renewable phosphorus sources. So how can we close the loop specifically on that? And then, of course, the use cases really differ. So if you're going to produce straws from winter reed, it might not return phosphorus to human consumption systems in the same way that if you're harvesting the green reed in summer and producing compost. So it really depends. I think the economics of it are key, of course, because that's how we can drive this engine forward. But I haven't looked into the economics enough, though I would love to. And I think this cost-benefit study that we did for Beachcast, it really should be replicated for different use cases of reed, so that we can really grasp this picture and be able to communicate not just the financial opportunities in each case, but also this what we call profitability for society. So this wider socioeconomic benefits, the environmental benefits tied in with, hiring people and all of these other things that we can put numbers on, and of course the willingness to pay for phosphorus uptake. So there are lots of different additional financial benefits, though they're not internalized within business. So I think, we need to do that work. Hope that is a satisfactory answer.
Thanks. Sonja?
I was thinking about, you had in this table where you had this blue table in below where you had this, and you had this for, this about values for phosphorus, this value of NMP removal. So I'm thinking, do you think this would be some kind of an incentive that we could start sort of working with, thinking about sort of on a governmental level in a way where we should start actually thinking about these also as costs actually for us somehow? Because today I think it's carbon we're talking about, but
biodiversity is another that's on the rise now. Yeah, absolutely. I just want to draw your attention to the yellow here, that these numbers were made up for the illustration. That the beach cast numbers, I think, might be taken from the paper, but I'm not sure. No, they're not taken from the paper. So, I think a table like this can serve its purpose to highlight these sort of different parts of the equation, and to show that monetary value can be, or sort of, the societal benefits should be quantified in some way, and that can help decision makers to make better decisions on what is really sustainable or not. This cost-benefit analysis framework is used to that end quite well, I think. It helps to boil down these complex issues and make sense of them in monetary terms, which is also a good communication tool.
Great. Yes, Peter.
Yeah, so kind of following on to that, and maybe the last questions that you had, are you, like from the academical side, are you involved in like pushing the politics or like proposing solutions on the more policy side, or are you involved in that at all?
Some academics are. I'm not myself. I have colleagues that may be more involved in that. There are lots of names involved in this project and in the beach cast that I haven't mentioned, who have been working hard with these questions for a long time, and I'm sure that they have personal contacts with policymakers and are pushing some of this, but I myself don't. Though I would like to.
Great. Any more questions for Jean-Baptiste? Otherwise, you can save it for the break as well. Thank you very much, Jean-Baptiste. Great presentation. Okay. We are at the end of the line, so I want to thank everyone again for showing up and everyone online. A lot of interest in this event, which is great, and we're going to continue. So next year, well, in 6 months, we'll be twice as many, maybe in Norrköping, hopefully. But no, and there's so much potential, really, and we obviously have a lot of challenges, but we're all here for the same reason, right? For the health of the Baltic Sea, or maybe the wider environmental issue. And I think we have so many organizations represented here, from research institutions to municipalities to private companies to NGOs. So I think, we can overcome the challenges, but we need to help each other out. So great. And thanks again to Manni med Svartling, and enjoy some coffee and snacks, and please make connections and all that. And there's a lot more information about the project and everything else. Please, you're very welcome to reach out to me or anyone else. So, okay, thank you.